Okay, in this video we are going to do the math behind proving that the integration of parts theorem works. It's basically the product rule done backwards, so I like to label it how to do integration by parts. So we're going to start with an f of x times one of those g of x's. And we know that by using the product rule, its derivative, that's equal to f prime of x, g of x, plus f of x, g prime of x. And now, if I do the integral of this, the integral of f of x, g of x prime, they both just cancel out, but I can still do the integral on both sides. Since it's addition, I could do the integral of each one. Okay, and we're almost there. In fact, the answer is really not going to seem so obvious once we're there, but it's there. I forgot to write my dx over here. Okay, so now if we have the integral of f prime of x, g of x, dx, which is exactly this one, all we're doing is moving this over here and that over here, we're going to say that that is equal to we aren't going to move it that way. We're going to keep this here. We're going to move that over there. That makes things a lot more simple. We don't have to multiply by a -1 at the end. Okay, there you go. And so this is it, if you'll believe me. All this means is that if we have some integral that we can identify one thing as a derivative of something and another thing that we can easily take its derivative of, we can write it in this form over here, and then we can evaluate it like that, like this whole thing over here, which would be a much more obvious function or integral to evaluate. So in the upcoming videos, I think I'm going to give examples of this. So right now, stay tuned. Thank you much for watching, and goodbye.